October 1942, a sprawling airfield in East Prussia. Steam rises from the wet tarmac as a massive bomber prepares for takeoff. Suddenly, orange flames lick around its engines and the crew scrambles to escape. This is the Heinkel He 177, Nazi Germany's most ambitious bomber and perhaps its most dangerous. Was this aircraft a masterpiece ahead of its time, or a technological disaster doomed by its own revolutionary design? Today, we're diving deep into the story of innovation, catastrophic engine fires, impossible design compromises, and a legacy written in smoke and flame. In the late 1930s, the Luftwaffe found itself caught between competing visions of air power. While Britain and America pursued strategic bombing doctrines with heavy four-engine bombers, Germany remained wedded to the concept of tactical air support. The Luftwaffe's leadership, shaped by their experiences in Spain and Poland, believed that precision dive bombing and close air support would win wars, not the carpet bombing of cities. However, by 1938, even the most ardent supporters of tactical aviation began to recognize the need for a long-range strategic bomber. Hitler himself demanded an aircraft capable of reaching distant targets, perhaps even America. The specifications were ambitious. A bomber that could carry 2,000 kilograms of bombs over 5,000 kilometers, capable of dive bombing like a Stuka, yet sleek enough to outrun enemy fighters. Ernst Heinkel, ever the opportunist and innovator, promised to deliver exactly what the Luftwaffe wanted. His company had already proven itself with successful designs like the He 111, and Heinkel was confident that German engineering could create a revolutionary aircraft that would combine the range of a strategic bomber with the precision of a dive bomber. It was an ambitious vision that would ultimately prove too ambitious for the technology of the time. The He 177 project was born from this perfect storm of military necessity, political pressure, and engineering hubris. The Heinkel He 177 was conceived as a technological marvel that would solve multiple problems with one elegant solution. To meet the Luftwaffe's demanding specifications, Heinkel engineers made several revolutionary and ultimately fatal design choices that set the aircraft apart from every other heavy bomber of World War II. The most distinctive feature was the coupled engine configuration. Instead of using four separate engines like the B-17 or Lancaster, the He 177 employed two massive DB606 power plants, each consisting of two DB601 engines joined together and driving a single propeller. This arrangement was intended to reduce drag and increase speed while maintaining the power of a four-engine bomber. On paper, it was brilliant. In practice, it would become a nightmare. Equally problematic was the dive bombing requirement. The Luftwaffe insisted that their new heavy bomber must be capable of precision dive attacks, a capability that necessitated massive structural strengthening. The aircraft had to withstand the tremendous stresses of pulling out of steep dives while carrying tons of bombs, something no other four-engine bomber was expected to do. This requirement added thousands of pounds of unnecessary weight and structural complexity. The He 177's sleek appearance masked these underlying compromises. Its smooth lines and retractable landing gear gave it the look of a scaled-up fighter aircraft rather than a traditional heavy bomber. The crew compartment was cramped and poorly laid out, with limited visibility and difficult emergency egress. Design flaws that would prove deadly when the aircraft's other problems manifested in combat. What appeared revolutionary on the drawing board would soon reveal itself as a collection of fatal compromises. The DB606 and its successor, the DB610, represented one of the most catastrophic engine designs in aviation history. These coupled power plants were essentially two separate engines bolted together in a single nacelle, sharing cooling systems and oil supplies while driving a single propeller through a complex gearing mechanism. The result was a maintenance nightmare that plagued the He-177 throughout its service life. Fire was the constant enemy. The tightly packed engines, with their shared cooling systems and fuel lines, created a perfect recipe for catastrophic failure. Oil leaks were common, and the supercharged engines ran extremely hot, often igniting fuel vapors or hydraulic fluid. Pilots reported that engine fires were not a matter of if, but when. The cramped engine compartments made firefighting systems largely ineffective, and once a fire started, crews had mere minutes to abandon the aircraft. Mechanical failures were equally devastating. The complex gearing system that connected the twin engines to a single propeller was prone to failure, often resulting in catastrophic vibrations that could tear the aircraft apart. Connecting rods frequently broke, pistons seized, and the cooling systems struggled to manage the heat generated by the tightly packed engines. Maintenance crews nicknamed the engines system disasters and dreaded working on them. Perhaps most terrifying was the unpredictability. An He-177 could take off normally, climb to altitude, and then suddenly explode in a fireball with no warning. Pilots developed superstitions and rituals, constantly monitoring engine temperatures and listening for the subtle changes in sound that might herald disaster. Many experienced aircrew refused to fly the aircraft, and those who did often wrote letters home before each mission, uncertain whether they would survive their own airplane, let alone enemy action. Despite its technical problems, the He-177 saw extensive combat service, particularly on the Eastern Front, where desperate circumstances forced the Luftwaffe to deploy even unreliable aircraft. The bomber's operational debut came during the siege of Stalingrad, where He-170s were pressed into service for critical supply missions to the encircled Sixth Army. These operations exposed the aircraft's limitations in the harsh realities of combat. During the Stalingrad airlift, He-177s flew dangerous low-level missions to deliver supplies to the besieged German forces. The aircraft's long range made it valuable for these missions, but its unreliability proved costly. Many He-177s never reached their targets, succumbing to engine fires or mechanical failures en route. Others managed to deliver their cargo but crashed on the return journey, their engines finally giving out after hours of operation in brutal winter conditions. The He-177 also saw action in anti-shipping operations over the Atlantic and Arctic, where its long range and heavy bomb load made it theoretically ideal for attacking Allied convoys. However, these missions often turned into disasters as engines failed over the open ocean, leaving crews with impossible choices between ditching in frigid waters or attempting to reach friendly territory on failing power plants. The aircraft's cramped crew compartment and poor emergency egress design made survival rates tragically low. Combat losses were staggering, but not primarily due to enemy action. For every He-177 shot down by Allied fighters or anti-aircraft fire, several more were lost to technical failures. The Luftwaffe's own records show that mechanical problems caused more He-177 losses than combat damage, a damning indictment of the aircraft's design. Units equipped with the He-177 suffered from chronically low availability rates, with aircraft spending more time in maintenance hangars than in the air, making them a drain on Germany's already strained resources. Flying the He-177 was an exercise in controlled terror that pushed even veteran Luftwaffe crews to their psychological limits. The aircraft's reputation preceded it wherever it was deployed, and experienced pilots often requested transfers rather than fly what they considered a death trap masquerading as a bomber. Aircrew accounts paint a harrowing picture of life aboard the Flaming Coffin, as they nicknamed it. Every engine start was a gamble. Would the coupled engines fire up normally, or would fuel vapors ignite in a spectacular explosion? Pilots developed elaborate pre-flight rituals, constantly checking temperatures, pressures, and listening for the subtle sounds that might indicate impending disaster. One pilot recalled, "We feared our own aircraft more than the enemy fighters. At least you could shoot back at a Messerschmitt." The psychological toll was enormous. Crews reported chronic anxiety, insomnia, and what would now be recognized as symptoms of post-traumatic stress. Many pilots wrote final letters before each mission, acutely aware that their aircraft might kill them long before they encountered enemy action. The cramped cockpit layout meant that if engines caught fire, which they frequently did, crews had limited time and space to escape. Emergency bailout procedures were complicated by the aircraft's design, and many crew members died in aircraft that might have been survivable in other bombers. German aircrew developed gallows humor to cope with the stress. Besides flaming coffin, they called the He 177 Luftwaffenfeuerzeug, the Luftwaffe's lighter, and flying torch. Some crews painted flame motifs on their aircraft, a darkly ironic acknowledgement of their machine's propensity for self-immolation. Despite these coping mechanisms, morale in He 177 units remained chronically low, and the aircraft's reputation made it difficult to recruit experienced crews willing to fly the dangerous machine. The tragedy of the He 177 was that its fundamental concept was sound. Germany desperately needed a long-range heavy bomber, and the basic airframe design had potential. Several attempts were made to salvage the program by addressing the aircraft's most critical flaws, though none came in time to make a meaningful impact on the war effort. The most promising solution was the He 177B variant, which abandoned the troublesome coupled engines in favor of 4 separate DB603 engines mounted conventionally. This configuration eliminated the fire-prone DB606/610 power plants and their complex gearing systems. Test flights showed dramatically improved reliability, with engine fires becoming rare rather than routine. However, by the time the He 177B was ready for production in 1944, Germany lacked the resources and time to retool factories and retrain crews. Engineers also explored removing the dive bombing requirement that had added so much weight and complexity to the design. A simplified He 177 optimized purely for horizontal bombing could have been significantly lighter and more reliable. Some proposed variants eliminated the dive brakes and heavy structural reinforcement, creating an aircraft more comparable to Allied heavy bombers in both weight and capability. Had Germany pursued a more conservative approach from the beginning, using proven 4-engine layouts like those employed by Britain and America, the He 177 might have rivaled the B-17 Flying Fortress or Avro Lancaster in capability and reliability. The basic airframe was aerodynamically advanced, and German manufacturing quality was generally excellent. A conventional He 177 entering service in 1941 could have provided the Luftwaffe with a true strategic bombing capability when it mattered most, potentially changing the course of the war. Instead, the pursuit of revolutionary technology created a bomber too advanced for its own good, consuming resources while delivering minimal results. The He 177's troubled history left an indelible mark on aviation development, serving as a cautionary tale about the dangers of pursuing revolutionary technology without adequate testing and development time. Its failures influenced post-war aircraft design philosophy, emphasizing incremental improvement over radical innovation, particularly in critical systems like power plants. The coupled engine concept, so problematic in the He 177, was largely abandoned after the war. Aircraft designers learned that the theoretical advantages of reduced drag and weight were far outweighed by the practical problems of complexity, maintenance, and reliability. Modern aircraft engines prioritize reliability and maintainability over marginal performance gains, a lesson written in the blood of He 177 crews. The He 177 also became a symbol of German wartime engineering philosophy, the pursuit of technical perfection at the expense of practical effectiveness. While German engineers created many remarkable innovations during World War II, the He 177 exemplified the dangers of over-engineering. Its story is often cited alongside other German wonder weapons as evidence that advanced technology alone cannot overcome fundamental strategic and logistical limitations. Modern aviation historians and engineers continue to study the He 177 as an example of how not to develop military aircraft. Its development process, with constantly changing requirements, insufficient testing, and premature deployment, violated virtually every principle of sound aircraft development. The program consumed enormous resources that might have been better spent producing proven aircraft like the He 11-1 or Ju-88 in larger numbers. Yet the He 177 also demonstrated the potential of German engineering when properly directed, as seen in the successful He 177B variant that came too late to matter. Today, the few surviving examples serve as monuments to ambitious dreams crushed by the realities of war and the limitations of technology. The Heinkel He 177 remains one of aviation's greatest what-ifs, a bomber that could have changed history if only it had worked as intended. Its story embodies the eternal tension between ambitious innovation and practical reliability, reminding us that in war, the perfect can indeed be the enemy of the good. If you enjoyed this deep dive into aviation history, smash that like button, drop a comment with your thoughts on the He 177, and don't forget to subscribe for more untold stories from the skies of World War II.